Hi friends, this is Rakesh. I am give a presentation on comparative study of analysis and design of overhead water tank using STAAD PRO and ETABS software. The objectives of the project are to analyze and design water tank using STAAD PRO and ETABS software, to observe the bending moment diagrams, shear force diagrams, and deflection diagrams for different loading conditions such as seismic load, wind load, dead load, and water pressure, to compare the results obtaining from both STAAD PRO and ETABS software, the literature survey. Next is methodology, how the work is done in a proper manner. First, analysis and design of water tank. This is the title of our project. First, done the literature survey, then go to the tank capacity. Okay, then choose the softwares. First I go with STAAD Pro. In that, first do modeling, then define parameters, analysis and design, report generation. In the ETABS also, first do modeling, then define parameters, analysis and design, then report generation. The reports coming STAAD Pro as well as ETABS, then you can compare, give results and discussions. Next one is specifications. Particulars, a diameter of the tank 10 meters. These are all our assumptions. Take height of the tank is 5 meters. Number of columns we take as 12, and column size is 0.3 meters by 0.3 meters, and the beam size is 0.23 meters by 0.3 meters. Thickness of the slab and wall is 0.15 meters. Grade of the concrete used in the design purpose is M30 grade, and the grade of steel is Fe500. Zone factor 0.16, response reduction factor 5, importance factor 1, rock and soil factor 2, damping ratio is 0.05. Analysis and design procedure in STAAD Pro. What are the steps followed in STAAD Pro LD analysis and design of a water tank? The following the steps are used. First, geometry of the structure, then define and assign the properties of column, beam and slab, create and assign supports, the 3D rendering view, load definitions and load case details, run analysis, post processing and design. This is the 3D rendering view of the structure. The 3D rendering view of the structure. These are the deflection diagrams. The first case for the seismic load, the second one is the wind load, the third one is dead load. This is for the water pressure. The next one is, these are the shear force diagrams. This is for the seismic load, this is for the wind load, this is for the dead load, this is for the water pressure. These are the bending moment diagrams. This is for the seismic load, this is for the wind load, this is for dead load, this is for water pressure. The steps followed in ETABS while analysis and design of a water tank are: develop the tank using cylindrical option, define material property, define and assign column, beam, slab and wall, create and assign supports, 3D rendering view, define and assign load cases, check the model, analyze the structure and go for the design. This is the 3D rendering view in the ETABS. This is a deflection diagram for seismic load, this is for wind load, this is for dead load, this is for water pressure. These are the shear force diagrams. This is for seismic load, this is for wind load, this is for dead load, this is for water pressure. These are the bending moment diagrams, the bending moment diagrams. This is for seismic load, this is for wind load, this is for dead load, this is for water pressure. The results and discussions. After designing, we take column reinforcement in the both cases in STAAD Pro as well as in ETABS and compare. The results are compared of column. In both cases we take Fi as 500, that is yield strength of the steel. Then FCK, characteristic strength of the concrete, is 30 in both cases. AST given in STAAD Pro is 720 only, ETABS also 720. AST percentage In STAAD Pro 0.894, in ETABS 0.8 only. Bar size for both cases 16 mm and number of bars are 4. The results after design of beam in STAAD Pro and ETABS are analyzed and compared. The results are Fi in both cases is 500 Newton per mm square and FCK is 30 Newton per mm square. Top AST in case of STAAD Pro 235.62, ETABS 208 and bottom AST is 235.62, 219 is in ETABS, but in both cases STAAD Pro same values are getting, but in actual practice bottom reinforcement is calculated manually. These are the conclusions. Conclusions were drawn based on the results. ETABS gave lesser area for required steel as compared to STAAD Pro. From the design results of column, comparison of results are not possible because of same AST. The analysis values in both STAAD Pro and ETABS software are almost similar, but the design values are little differ. Analysis was done by using STAAD Pro and ETABS software successfully as per the IS 456-2000. Usage of ETABS software minimizes the time required for analysis and design. STAAD Pro software is more flexible to work compared to the ETABS software. The quantity of steel requirement is 8.82% less for the design of overhead water tank using ETABS compared with STAAD Pro software. The quantity of concrete requirement is same for the design of overhead water tank using both STAAD Pro and ETABS software. These are the references I follow to complete my project. Thank you.